Hello guys, we're doing some intermediate algebra today, and I can't believe fall break's almost over. Tomorrow's the last day of our fall break in my public school system. So yeah, anyways, this is the first problem in all of aops intermediate algebra. So we're looking at a quadratic equation, and then we're trying to find the value of the square of the roots, their reciprocal sum, and then we're trying to express them in terms of the coefficient. So let's take a look at what this is. So we have 1 over r squared plus 1 over s squared. I'm pretty sure that's what it is. I don't know why they would name them such weird stuff, r and s. Maybe that's a common way to name roots. I don't know. I'm not a math person. I'm a coder. Anyways, we have 1 of it, and we have those two added up together, and we're trying to find what they are in terms of coefficients. So we obviously can't just solve for r and s in terms of a and b because that's going to give us a huge thing, and our answer choices are quite simple. So there's got to be another way. And in this case, we automatically think of Vieta's formula because we have the two roots and also some kind of a sum. So if we can somehow turn them all into forms of rs and r plus s, then we can use the Vieta's formula on this equation. So let's first of all just try adding them up together. So the numerator will obviously, numerator is a little bit more difficult. The denominator obviously will become r squared s squared, right? And then notice that r squared s squared is obviously just rs, this whole thing squared. So we have the denominator figured out because rs is just going to be c over a. And then let's take a look at the numerator. So the left side is 1 times s squared, so it's going to be s squared plus r squared, right? Because we're trying to commonize the denominator, so we get this for the numerator. And then how do we further simplify this so we can use Vietas on it? Notice that s squared plus r squared is just s plus r, this whole thing squared, minus 2sr. I know that's like a not very obvious notice unless you're like an actual math person, but if you're a coder like me, it's not a very obvious notice. But the reason why this is true is because s plus r squared is equal to it's equal to s squared plus 2sr plus r squared. So s squared plus r squared is just this whole equation minus the 2sr term in the middle here. So now that we have it in this form, it's all going to be easy because s plus r is just going to be negative b over a. And then sr is c over a. So now we have this whole equation turned into this part right here over this. And then notice that everything is either in rs or s plus r. So we can just apply the Vs formula using these two and find that the answer will just be D. Yep. Now let's take a look at the second one. The area of a square inscribed in a semicircle is to the area of the square inscribed in the entire circle as what? Pull up the drawing board. The circle tool, so I'm just going to use that. Yep, not best circle, but we're going to go with it. We have a square inscribed in the large circle. Yeah, not a perfect square either. And then we make a semicircle, and then we also inscribe the square in the semicircle. Oh, this one's actually not bad. And okay, so first of all, let's clarify the center, let's say, is right here. And how do we find the ratio between the areas? Well, we can find the ratio between the side length, so let's find the side length of the bigger square first. The bigger square, the side length, is rather easy to find because obviously we know that this is a 45, 45, 90 triangle because obviously these two angles are congruent, so then we can just note that half of the side length is r over root 2, right? Because 45, 45, 90, and this is r, so r over root 2 is half, so the entire side length is 2r over root 2. And let's take a look at the smallest square. Just erase all these. The smaller square has the radius connecting from the center of one edge to the vertice of another corner. So how do we find the side length using this? Notice that this time r is equal to 2 times, no, not 2, 1/2 times the side length squared plus the side length itself squared and then square root, right? Because Pythagorean theorem, this is side length and this is 1/2 side length. So then we solve the equation to find that. So we can also just do this entire thing. We'd have to solve it, this entire thing, over the side length in the big square is, what was it again? R equals side length. No, side length equals R over root 2. So R equals side length over 2 times root 2. So then we just have to, this is going to be the top part of our fraction. This is going to be the bottom part of our fraction. If you're going to read my handwriting, and then we divide those to find the ratio. And then do not forget that we have to square the ratio, because this is only the ratio between the side length, and we're actually trying to find the ratio between the areas. Why can I not? All right, but okay, that's better. So the ratio between the areas is just going to be 2 to 5, because the ratio between side length after you solve the equation is going to be square root of 2 to square root of 5. So yeah, so the key part about this problem, even though it looks like geometry, the key part about it is really solving how to set up the equation, which in this case is going to be this thing, and then you just solve the equation pretty naturally. And then you don't even actually have to get rid of the square root, because at the end you just get a root 2 over root 5, and then you just square both sides. I mean, square top and bottom. So then you get 2 to 5 for the area. Yep. So yeah, that's it for the video today, and I hope I can make another video last day of fall break tomorrow. There's 22 days till, 22 days till AMC 10A. Yeah, well, yeah.